All right, moving into 10-2, day 1. We are going to focus on only one shape today, and that is the circle. And we'll talk about review the parts of a circle. So, remember, a circle is defined as the set of points equidistant from a given point. That given point is our center. And then the distance from that center, if I was to hold that steady and I had a string here, I could draw this circle. And that distance away is our radius. And the distance all the way around the circle, if you remember, is our circumference. And if we take the distance from one point on the circle through the center straight off to the other ending point on the circle, that is our diameter. So if you put two radii together, you get a diameter. Alright, diameter. Sorry about that. But, so, our formulas were going to be, well, first of all, let's go A, B, C, D. So, radius, segments that would represent the radius in the circle would be segments CA, CB, and CD. Each of them is the same length, and they're each equal to the radius. The diameter, the only one I have drawn in here is segment BD. And a diameter is two radius lengths. There's a radius here and a radius here. All right. Okay, now our formulas. For the circle, we're going to talk about two things. The distance around, which is known as perimeter, but we call it circumference. So the circumference of a circle is, the book will say 2 pi r. 2 times the value of pi times the radius. I like to, because 2 times the radius, 2 r's make a diameter, I like to call the circumference pi d. Pi times diameter. But you can go with either one. They're the same thing. So 2 pi r or pi d, I will 9 times out of 10 use pi d. So circumference, again, think of it as perimeter. The distance around. And then we've got the area, the amount of square units inside of the contained circle. That's area. And that formula is very familiar. Pi times the radius squared. So, if you have that note sheet started, let's add those two formulas to the sheet. So we've got our circle. Where we're going to show a radius. And a diameter. Circumference is pi d or 2 pi r, and area is pi r squared. So everything's going to be handy here. Okay, all we have are about 5 examples. It's a pretty easy day. When we get to the last shape, that one's a little bit tougher. That's our hexagon, but we'll spend another day on that. So, first one. If we have a circle with diameter equal to 6x inches, find the area and circumference in terms of pi. Area and circumference in terms of pi. All that means is pi is going to be visible. You won't have to pick up a calculator, more than likely. So let's start with circumference. I always like to write down the formula first. Pi times diameter. I'm going to use capital D for diameter. So the pi just stays. The diameter is 6x. And now it's just a matter of rearranging this so that it's in a proper order. And usually when there's a pi, pi is at the end of the answer. So we will pull the 6 and the x to the front, and that will be our circumference. I know that's an ugly thing because the x is in there, but there's nothing I can do about that. Now the area, our formula is pi times the radius squared. So notice I gave you the diameter. We need to know the radius, so you just have to know the relationship between diameter and radius. Well, a diameter is 2 radius lengths, so all I've got to do is just cut this in half. So if the diameter is 6x, that means the radius is going to be half of that, or 3x. Now I just take that, substitute it in for the r, I have to square that radius, and then keep the pi. So it's pi, I'll go baby steps. Now be careful, I have my radius is 3x, and I need to square that. Now if you look at that, what have I actually squared? I did it this way because lots of students will make this mistake. I've only squared the x, where the radius does have a 3 with it. So to do that properly, I have to square both parts of that. So now, again, baby steps, I need to square the 3 and the x. So keep the pi, that's not squared. That's going to go to 9. And then the x will just go to x squared. And then just like over here, we float that pi to the end of the answer. 9x squared pi will be our area. Okay, that was a little ugly with the x, but you can handle it. Number 2. If I give you the circumference is 24 pi inches around, can you find the area? So, here's what I've got. I've got a circle, and I know the distance around this thing is 24 pi. Our goal is to find area. Well, in order for us to get the area, I have to know one thing, the radius. But I've got to start here and work backwards. I know this is the circumference, and I know the circumference is found with using the diameter. Because to get 24 pi, that's equal to circumference. Circumference is, if I substitute the formula in for circumference, I can put pi d here. Direct substitution of circumference equals pi d, putting pi d in for the circumference, keeping the 24 pi. I can do algebra and figure out what the diameter is. Well, this is pretty easy because I can just divide both sides by pi. I don't need a calculator because I can cancel. I can see the diameter is 24. So all the way across this thing is 24, which now makes the radius, if I cut that in half, 12. Now it's a very easy junior high problem. Area is pi r squared. I feel like I'm going fast. Hopefully you can slow it down if you need to. Pi times 12 squared. So squaring the 12, that's 144. And again, the pi floats to the end of an answer. 144 pi, that would be square inches. So that's leaving pi visible. If the book asks for a decimal place, like usually 2 decimal places out if they want, then you just pick up a calculator and you go 144. You don't even have to put the times symbol in. Otherwise you can times by pi. And that's about 452. We get to the point where we don't multiply because then you have to have a calculator, where this is much easier without a calculator. So get used to seeing the pi. Number 3. Oh, very much like this one. This one was pretty easy. I didn't need a calculator. Watch what happens here. Same thing. This time the circumference, I'm going to try and squeeze this in here, is 15 centimeters. Can you find the area? So, again, we've got to work backwards from circumference, and then once we find the diameter, we'll get the radius, and then we'll come back for area. So, I'm going to start with that formula, pi d. I'm going to substitute the 15 in for the circumference, because I know that's what it is. I'm going to solve for the diameter by dividing by pi. So the diameter is 15 divided by pi. Okay, I need the radius. So I have to cut this in half. So cutting that in half means I'm going to times it by a half. That'll be the easiest thing to do when there's a fraction there. So the radius will equal the diameter, which is 15 over pi, multiplied by a half. So I will get a radius of 15 over 2 pi. So now we're ready for area. Area equals pi times that squared, and I'm going to put it in parentheses because there's a lot going on in there. 15, that's a bad 15, over 2 pi squared. Okay, there are 3 values in here. They all have to get squared. So I'm going to keep this pi. I'm going to make it pi over 1 because it's going next to a fraction. That keeps all my numerators and denominators lined up. Squaring the 15, that's 225. Squaring the 2, I'll get 4. And then squaring the pi, I'll get pi squared. And now it's just a matter of simplifying. The first thing I can do is reduce a value of pi. This pi will go down to 1. Then I will have one of these left instead of a squared. So I've got 225 over 4 pi. I can leave it like that. If you really want a decimal for it, that would be my final, for me that would be my final answer. Otherwise, I would take 225 and divide by, and because there's 2 numbers down here, I need parentheses around that, 4 pi. Otherwise, if I go 225 divided by 4 pi, it looks good, but I will not get the same answer. Because what this line is doing, it divides by the 4 only, gets that answer, and then times by pi. So be careful on that if you're going to pick up a calculator. Okay. 2 left. Number 4. Another one where we're going to work backwards with some. These are tough with the algebra. So here we go. We've got a circumference equal to 65x plus 14 pi. Feet are the units. And our goal is just to find the radius. What does the radius equal? Okay, all we've got to do is work backwards, but you have to have a formula to work backwards. So in place of the circumference, I can put the formula, pi d, equals the value of the circumference, 65x plus 14, pi. Remember, my goal, keep your eye on the prize here, our goal is to solve for the diameter. So I have only got to do one algebra step here, and that's get rid of this pi. To get rid of that, we're going to be dividing. So I'll divide both sides by pi. Very easy to do there. Very easy to take care of here. So now I know that the diameter equals 65x plus 14. So I know that the radius is half of this. Okay, before I times by a half, because I had a fraction. This one's not a fraction, so I'm just going to divide by 2. I'm going to divide the diameter by 2, divide by 2, divide by 2. Dividing that by 2 gives me the radius. Half of 35 is 32.5. And then half of 14 is 7. Hopefully that algebra's not stumping you too bad. All right, our last one together. Here we have the area of this circle is 25 x squared pi square inches. Can you find the circumference? Okay, so to get circumference, I need to know the diameter. What we can do is work backwards from area. Whatever they give you, we work backwards from, if it's not directly what you need. So we'll start with the area, and then we'll come back to this. This will be second. So first, I know that the area of a circle, the formula is pi r squared. I can put the value in for the area and then solve for the r. So, in place of area, I can substitute in 25x squared pi, leaving the formula here, pi r squared. Working backwards, now my prize is solving for the radius, so that I can then double it to get the diameter and plug it in here. So, first algebra step, leaving the r here, is get rid of the pi by dividing. No calculator needed because there's one on each side now. So I've got 25x squared equals the radius squared. So remember, how do we unsquare something? That's square root. So square root of r squared is r. There are two items in here, both have to be square rooted. So what number squared gives you 25? That brings us out to a 5. What squared gives you x squared? That's just x. So our radius is 5x. Now, circumference, so that means the diameter, we got to double it, so we'll times it by 2, we'll get 10x. We're not squaring it, we're doubling it. So I just get twice as many. So circumference then is pi times 10x. Flip-flop my order, float that pi to the end, and there it is. Okay, that ends our circle note.